Hi, I'm Pat Kelly. Okay, and in this problem, our challenge is to find a k such that this function they give us, k parentheses 4 minus x squared, over the interval negative 2 to 2, ends up being a probability density function. So I got to tell you, this is one of my favorite types of problems. It's not just turn it through a crank, get the right answer, and feel good about yourself. Instead, we have to do a little bit of thinking, do some work, get the right answer, and then we have the right to feel really good about ourselves. So let's see what's going to be involved. For this problem, our ultimate goal is to find the value of k such that this function is a probability density function. So I'll start by thinking about what it's going to take for this function, or any function, to be a probability density function. It comes down to three things that we need. So in this problem, I want the following three things. In order to be a probability density function, f must be continuous. F must be non-negative. And then finally, the integral from a to b of f of x dx needs to equal 1. Now in this problem, as it's given to us, we don't necessarily know if any of these three conditions are met. It's going to come down to what value does k equal. And it's our job to find a k. So these are the things that I want. And so I'm going to try to figure out what it takes on k for each of them to be true. The first thing is, this is actually just a polynomial. It's a quadratic. Because k, remember, through this whole problem, keep in mind that k is a constant. So k is a constant, like 5, 7, negative 10. It doesn't have any x's in it. So the highest power of x is 2. This is a parabola. It's a quadratic. The graph is a parabola. This is continuous. Next, I'm going to address the f being non-negative. I know it's a parabola. I'm going to try to think about what the graph of this looks like, even though I don't know what k is yet. So some things that I do know, it's a parabola. It's either going to open upward or downward. And if I even do a real quick check on the value of the function at those endpoints of the interval, I can take a negative 2 and plug it in for x. Negative 2 squared is 4. And 4 minus 4 is 0. This works out really well for us because it doesn't matter what k is. This is going to be 0 times something. So this equals 0. And if I check that other endpoint of the interval, 2 squared is 4. 4 minus 4 is 0. It also ends up being 0. That's helpful for me because if I'm trying to picture the graph of this thing, I know that it has those x-intercepts. And I know it's a parabola. So it really just comes down to whether or not this is a parabola that opens downward or a parabola opening upward. It's really important for us in this problem because over this interval, this function is supposed to be non-negative. So we really need this parabola to be opening downward. Non-negative meaning that the graph is entirely above the x-axis or on the x-axis. So back to our parabola. Whether it opens upward or downward is determined by the coefficient of the x squared term, which is right now negative. That's going to be a downward opening parabola. My only concern is that we don't know what k is. It's a constant, but it could be negative. And if k were negative, the negative times the negative would be positive, and it would be an open upward parabola, which would not be good. So what I need is for k to be greater than or equal to 0. This condition we just figured out assures me that the parabola is going to open downward, which means that the function is non-negative. All right, now we'll focus on that third bullet. This is our big ticket item. This is what we want to make sure is true. Make sure all of them are true, but this one's going to involve a little bit more work. We need the integral of this guy over negative 2 to 2 to end up equaling 1. So the integral from negative 2 to 2 of k parentheses 4 minus x squared dx. What I'm not going to write yet is the equals 1 because we don't know what this equals. This is our job right now, is to figure out what this equals and then force it to equal 1. So really what it's going to come down to is doing the work for this integral and finding out an answer for it. You'll see that the answer is an expression, and our job is going to be to force that expression to equal 1. Let me show you. Okay, to start with my integration, as I mentioned, k is a constant. Keep that in mind through this problem. So even in our work with the integral, k is a constant factor on the inside of the integral, which means you can pull it outside. That would be my first step. Because then notice the integral part of it is something I can handle. I mean, I don't know what k is yet, but I can definitely simplify this integral expression. So let's do that. And I do have to keep the k in front, but now I'll work on that integration. So my antiderivative would be 4x minus x cubed over 3. And it's a definite integral from -2 to 2. Now I'll just evaluate the limits of integration. So 8 minus 8/3, subtract, minus 8 minus a minus 8/3. And all of that is going to be multiplied by the k. Okay, so that was just our integration step. Now I'll clean it up a little bit with some arithmetic. What we should get, 8 plus 8, 16. 8 minus 8/3, 16/3. And then a little bit of arithmetic here. I'd get the common denominator of 3. 48 minus 16 is 32/3. And that ends up being our answer to this integral. We worked out the integral, and even though we don't know what k is, we get the expression of k times 32/3 for our answer. So now I'm going to go back to my wish list here. I wanted that integral to equal 1. So I still want this integral, 32/3 times k. I'm going to set it equal to 1. That's me saying I want this condition to be true. I don't know what k is yet, but I want that answer to the integral to equal 1. Now we'll just do a quick algebra step to solve for k. Multiply by the reciprocal, and k equals 3/32. What that tells us is that if k equals 3/32, that third bullet is satisfied. First bullet was that we had continuity. We had that. Second bullet was telling us that k needed to be greater than or equal to 0, and it is. So we have a check mark there. A check mark on all three. And so for this problem, we did find a k such that this function is a probability density function. And hopefully you feel pretty good about that. We did some pretty good work there. Hopefully that helps you with some of the other problems too that have k's in them. Okay, thanks very much.